And so today I'm going to talk to you a little bit about evolution and revolution. Okay? Some of those pegs are evolutionary, and some of those pegs are going to be revolutionary. And I want to go into that a little bit because then that'll help explain the story of data and what are evolutionary changes and what are revolutionary changes, right? I collect maps, right? And this is a map way back, 1776, by John Ogilvy. And this was a revolution. Up until this point, maps were a map of London, a map of Land's End, a map of Canterbury, right? But people were in horse and coaches going down highways, and they didn't want to know what was on the left and the right. They wanted to know what was on the road, right? So he came up with the concept of strip maps, right? You went from point A, London, to point B, Land's End. And along the way, you know, you had points of interest, right? You may want to know where the local inn is. So you can grab a pint of beer and hay for the horse, right? Pedal forward a few hundred years. We have a map. It has a starting place in London, and it has an end destination, Land's End. That's all you care about, right? And on the way, there are points of interest, right? You may want to stop at Karl Marx's tomb on the way. You may want to get a beer. Definitely no straw for the horse, but you may need to top up some gas on the way. It essentially does the same thing, right? So whether you're on a horse and buggy, you know, with your strip map from John Ogilvy, you know, whether you're on a roadster in the 60s, you know, picking up your fold-out strip map, you know, from AAA at the local gas station, you know, whether you're in a sedan in the 90s, you know, late 90s, early 2000s with your Google map trusted on your side, or whether you have it on your phone a few years later, you know, in 2007, or whether, you know, in a Tesla, right, with your built-in tablet. The first tablet in the history of tablets was built into the first Tesla. All of those things are derivative. They evolutionary, and they're accretive. But the revolution started in 1776, right? Let's look, you know, back at the now defunct Comdex, right? 2001. Bill Gates, super excited, right? With this super cool tablet, right? This was going to change the world. But the experience was evolutionary, right? Because it had a stylus. Go forward a few years. This guy, what did he say about styluses? Anybody know? He said, you're born with 10 of them, right? And so the revolution was here, not back with the tablet. It was in pinch and zoom, to go into data, to explore. This was the revolution that excited the world and has got us to where we are today. So what you need to understand is that revolutions are platforms for change, right? They strong and they support a huge structure, right? So I want to take you way back now, as I said, 2,500 years back, to written language. And that is the first data revolution, right? Up until that point, right, we lived in villages, small communities. And if you go and you research small communities, you realize that there's basically a 150-person threshold. Up until 150 people, you're pretty good at running a family clan, right? You're chief of the village, right? And if you had 150 people in the village, you probably know them by name. So from a data perspective, it's really easy to say, dude, that's illegal. You know, I'm going to kick you out of the village. We're going to penalize you, right? We kind of have some control. Over 150 people, we get into cities. It's very difficult, right? You have to have something that's codified, something that's written down. We know this from businesses. I'm sure a lot of entrepreneurs out there, right? When you run a family business, you know, it gets bigger. You still know everybody's name, especially if they're in your family, hopefully. But then you get to 50. I've run businesses, 50, 60, 80. It starts to become really difficult. You don't know everybody's name, right? So at 150, most businesses go through a bit of a crisis. And they have to become larger corporations with mission statements and values and all these things have to be written down, right? So written language was really, really important because it allowed us to build smart cities. Hell, smart cities don't start now. They started in the beginning of written word, right? Because something like this allowed us to, for example, 2,500 years ago, you know, the Sumerian governor in Iraq got to write down all his silver holdings, right? It's like a blockchain key that you write down, you put into the safe. Same idea, right? He got to write it down. And the reason that written speech was so important was it had an open architecture. It was permissionless. You didn't even need permission to write. Didn't need permission to read. It was decentralized. It was all over the place, right? And interoperable. And a platform for products and services. And key, it was a commerce enabler. So as a smart society, we started to grow really rapidly because now people who are really smart could speak to other people who are really smart. Then amplification went beyond your little clan. So, you know, Hammurabi's code, law, eye for an eye, it got written down, right? And the Gutenberg press was great. You know, we started to get more efficient at writing. And because of that, you know, the Magna Carta, you know, we worked out that the world was rounded and wasn't the center of the universe. You know, we worked out, you know, origin of species, thanks to Darwin, and all these documents through to Albert Einstein. These were revolutionary documents, but they sat on a platform called written word. And because of that, we progressed as a society really rapidly. But they were all inventions that sat on top of written speech, the written word, which was derivative, evolutionary, and accretive, right? So let's just take an example of a smart society. Back in the Middle Ages, you know, we had the Black Plague, okay? 25 million people died in Europe because of this guy, right? That was the time that we believed in diebucks and fairies. Nobody would have thought that this little, you know, microscopic flea was the cause of this. And because of that, between those years, 50% of the population was killed. 50%. Pedal forward to today. Here we just had Ebola crisis in Africa, right? 30,000 people were infected, 11,000 dead. Now that's terrible. But it is 0.00003% of the local population. We're a smart society. We got to evolve what we do based on written text, records, and data. Next revolution was mid-last century, when we came up with a protocol which allowed computers to speak to other computers. TCP IP, right? So back in Berkeley, UCLA, Stanford, these nodes worked out how one computer could talk to another computer. Now think about that. If I'm smart and I can talk to another smart person, we have an amplification on data and smarts, right? If we get to a point where there's too much data and computers can process that information faster, then one computer speaking to another computer is a quantum amplification on our ability to be smart, right? So TCP IP was the next revolution. And Vince Cerf and the wizards that stayed up late inventing the internet made it a revolution because it was an open architecture, it was permissionless, it was decentralized, it was interoperable, and it was a platform for products and services, and most importantly, it was a commerce enabler. And that's why we're here today, because we're talking about all these smart applications that we can apply to our cities, fantastic things that were all built on this foundation. And then on that foundation, we started to build things to make it more robust. So we had, Tim Berners-Lee inventing HTML, HTTP, URLs, and bam, we had the World Wide Web, right? Amazing, right? So now we started to build this, and this became this new evolutionary phenomenon that we have conference after conference on, and we have company after company developing things on. And what was the biggest thing that drove this? Was the act. It was the ability to send things from not only one computer to another computer, but one person to another computer, and another person. So amplifying data, amplifying fluidity in data. And again, so we had ARPANET, DARPANET. Building on that, we had obviously TCP IP. We had the whole idea of the internet with Tim Berners-Lee and how this mesh network would work. We had on top of that browsers come into the picture with Mosaic. Remember dial-up browser, so exciting. And then things started really happening when we started to develop content and social networks, and Facebook turned into everything we know today as the modern internet. And then remember the inaugural dance with Obama, and you just pan back a bit, and wow, look at all that data. Sharing data everywhere, images, video. This was a phenomenon. And you would say, wow, that's so revolutionary. Well, that is amazing, but it is a derivative, evolutionary evolution of what we started as TCP IP, right? And then we have this proliferation of images everywhere in the world. But how do you make those images smart? Well, so we have to train those computers that speak to each other through TCP IP to be smart. And we have to treat them. Turing, who sort of invented the first computer, talked about the child machine, right? You can't just give data to a machine and think, oh, you're an adult machine. Here's a lot of data. You're good. No, sorry, I don't speak data yet, right? So you have to treat them like a child, right? You have to grow those insights, and that's sort of machine learning, right? And so here's an example from the Stanford Computer Vision Labs of this network they created called ImageNet, and they used Mechanical Turk, and they got people to take images and put a description next to it, right? So this is a boy holding a ball in the backyard, and so there was data and there was images, and the computer then could digest that. They took 15 million manually classified images, right? And so, what is that? Oh, well, it has a round face, right? And it's got 2 ears, and it's got this kind of cute face that's sort of connected with a little nose in the middle, and it's kind of fat and tubby, and it has a tail. That is a cat. So now the computer can extrapolate and say, well, if that's a cat, then that's a cat. And that's a cat, right? And so now these computers, they could talk to each other, started getting really smart. And so I was in Curacao, I think a year and a half back, and Howe was talking about safe cities, right? And how they could take all the images of the people in that city and recognize them, and then extrapolate things like, well, that's a bad actor. That's not a bad actor. Well, we have to take action on that. And so what are computers? What is big data? What is machine learning? What is AI? Well, all they are is this high fidelity approximation limited to a data set. You have a lot of data, you start getting really smart, right? And then you use TCP IP to sort of move things around, and you start to get a whole lot of businesses, right? And so you can analyze people's images because you have so many images to analyze with data attached to it. And then you have things like this year when Google comes out with Google Clips. Google Clips, have you got one? Okay, continually takes photographs. Continually takes photographs, so you can put it on your lapel, you can put it in your kid's bedroom, hell, you can put it in your bedroom. And it will take photographs continually, right? And you know, it'll take out the blurry ones, we'll keep only the good ones. And you know, well, from an innocent perspective, you know, you can have wonderful photographs of your kid and it's stored in the cloud and you're happy, right? There's Echo Look, right? Everybody have a personal assistant in their house? No? Who does? Have you got Google Home or Amazon Echo? Anybody? Wow, I got the wrong crowd. You got to get one. So this particular one has a camera attached to it, right? So not only can you ask it something, right? But you can ask it something that goes beyond text, right? It goes beyond voice. It'll take photos of you and create a lookbook for you. You remember the last time you were changing and you took a picture of yourself and you sent it to Sally and you said, hey, how do I look? And you say, you need a scarf with that, right? You know. Well, now, because there's so much data and it's recording what's in your wardrobe, it can say, hey, dude, change the shirt, right? And it can go up and do a style check with virtual stylists, it's a style guy in the cloud. And they can say, you know what, in France, they're wearing scarves tied this way. Would you like to order one, right? And so, and Amazon, you know, is the, you know, blue-eyed, you know, child of data, and it is exemplary on using data to be more efficient, using the protocols of the internet, using that revolution that started at TCP IP to do things that no other company is doing at the scale that they are doing, right? And because of that, all these wonderful retailers that, you know, I used to work with back in the day are kind of going out of business, right? Here we have, look, this is a year back, you know, 2,000% growth, right? And all the other guys, you know, Walmart is just eking out a 2% growth. So what does that mean? Well, it means that each of the verticals are now being hugely disruptive, right? Stores are closing, the internet is more efficient, and it's all based on this evolution of data and smarts on top of that data, right? And so we started with organic algos. We're all algos. We're all algorithms, right? We look at people and something processes inside and we come up with some epiphany. Hey, it's Bob. How you doing? You know, how's work? I remember you have a kid, right? Oh, we're an algorithm. But we can't process things fast enough, so we need silicon algorithms to augment the organic algos, right? And that's the fourth industrial revolution, right? We talk about, you know, machine learning, AI, IoT. That's the fourth revolution on the industrial age. But from the data perspective, it's fairly evolutionary, right? And it's all based on this thing called social physics, connecting you to your bank, connecting you to your purchase habits, your social media, and working out on a crowd basis what you do and what the crowd will do. That's social physics, right? And we can do that really effectively, and it may surprise you, right? So anybody here has a Facebook account and still use it? Yeah? Okay, no? Wow. You're a tough crowd. Okay, so say Facebook. Let's say I went on Facebook and I did 5 likes of things. Articles, people's images, right? Those 5 likes would give me enough data insight to match any insight that your work colleague would have of you. Just those likes, 10 likes, okay? 70 likes, dude, I'm like your friend. 150 likes, I know enough about you to rival a family member. Just 150 likes. 300 likes, we're married. Okay? Isn't that crazy? It's crazy, but it's true. We're just a bunch of clicks, man. And so I love this because Waymo, which is an Alphabet company, they have the leaders in the autonomous driving vertical. They just came out with a patent where they not only have intelligent airbags in the car, but now they have patents on airbags externally. Okay, why would you want to do that? Well, because I drive so safely, dude, because I'm a computer, I don't need to worry about as much my internal safety. I have to worry about those idiots riding around, those organic algos that keep on driving into me, walking in front of me. I gotta protect them, right? The world's changing. So we started off, in this journey with data as this oracle, right? Knew a lot, it could help us, right? And then it became sort of, a smart assistant, right, with Echo, and now it kind of rules the day. It knows more about us, it can do things without us, right? This is super intelligence, right? This is the Leviathan. And so we've gone from computers as oracles to computers as assistants, and now computers as sovereigns, right? Which is kind of a little bit scary, right? And it gets more scary every day. So we have, Julian, who was this, super hacker from Queensland, Australia, and he started, I think leaks.org and then WikiLeaks, and we know the kind of, fear that brought into our politics and journalism, how it really has changed the way we see data and information and privacy, right? And that started before Julian. I mean, this started in the cypherpunk movement in the 90s, where blockchain started, right? In the cypherpunk movement, they tried to create currency. They didn't have a platform for it yet, but BitGold and all these cryptocurrencies started in the 90s. And it was all about, hey, dude, I've got my thumb drive and my shotgun under my pillow, I'm good, right? Libertarians, not too happy about the Leviathan sovereign idea, right? And you've got, Aaron Schwartz, who was a hacktivist, eventually arrested for taking academic journals and publishing them to the World Wide Web, pay for use academic journals. He believed that data belonged to the people. He believed information needed to be free, right? He was arrested, and before he went to trial, he committed suicide. And then the story continues, right? Snowden, and then the bank debacle of 2008. Suddenly, those banks were not accountable. Do we really want our data there? Are we scared? Are we concerned about what they will do with everything that we used to hold sacrosanct? That trusted economy, right? And then more recently, hack after hack after hack, you got Equifax, which was a big hack, because this was our data. This was who we are as organic algos, right? And suddenly other people know about us, can impersonate us. So that trust, that circle of trust, have you, Meet the Fockers? Have you remember the movie? Way back when? Right? Remember that? Ben Stiller bear hug with Dustin Hoffman, right? It was all about trust and relationship. That touchy-feely thing that's so important to us humans. And then, not so touchy-feely, right? It was more about the data. And hold on a second, give me your data, because I need to know a few things about you, right? It's just not so comfortable for us organic algos. And then you go, oh my gosh, it's sovereign. Somebody controls my data. I don't know if I feel so comfortable about that, because I'm outside the circle of trust, right? So now you get the blockchain. That's our third revolution, the blockchain. So what is this blockchain thing, right? Well, so you had things like Amazon, right? Which is centralized data, right? So all that information, whether you trust Amazon or not, they have centralized data. They know a whole pile about you. Facebook, centralized, right? And then you got decentralized data that's a little bit like eBay, but still, it's controlled by some central authority. Now, you have to believe that that central authority is trustworthy. That's Ben still a hug. I love you, man. Look after me, right? And then you have the blockchain, which is totally distributed. So all these nodes on the blockchain aren't in one place, right? So you can have a node, ultimately all working together to make sure that the nodes all align, right? So that the data is clean, right? So we're hashing together, and you take any image, you hash it, you take any data and you hash it, you come up with the same number. So if you change one iota of the data historically, you change a 1 to a 2, different hash, you're not going to be able to lay the next block, right? So that's a different way of looking at data, right? And we talked about the cypherpunks, right, who tried to put together a new way of treating data, but they didn't have a backbone for that. And then we got, Satoshi Nakamura, who came in and said, look, I got an architecture for that, which is basically got around the double spend, right? So I get, in the physical world, if I had $1 and I gave you $1, I didn't have the dollar, you got the dollar because it's a physical dollar. We couldn't tear it apart. If we tear it apart, I have half a dollar, you have half a dollar. It's that's how dollars work, right? Up in the ether, up in the internet, I can have $1, I can send you $1, I can keep my dollar. I can send you an image, I have the image, you have the image, right? So that we have to work out a way that things don't double spend, right? And that's what the blockchain did. It was open architecture. It was permissionless. It was decentralized. It was interoperable. It was a platform for products and services. And oh my gosh, was it a commerce enabler, right? And the world kind of changed. So what is a country, right? If you don't have fiat currency, and this cryptocurrency sort of floats around. What is a country? What demarcates borders when smart contracts don't apply to one given jurisdiction, right? And the companies too. Where are the lines between those companies if there's no central database, right? It's just a thin data layer, right? And suddenly you can have contracts which disintermediate, the lawyers and disintermediate law enforcement, right? And you can have, an asset supply chain disintermediates things like Carfax, right? Because now the product I put as a smart contract, and I can follow it now as an open ledger right through its life cycle. Everything is out there. Everything is transparent from birth, cradle to grave. And records and identity, and payments and remittances and lending, disintermediate guys like Google have your sovereign identity, and banks, and even governments. What's the role of government? If I can put everything as a smart contract, my identity, what I buy, the bank, all my assets, all can be put out there without any sovereign overlay. So, look, it's early days. Bitcoin processing at 3 transactions per second. Ethereum, a little faster, 5 transactions a second. Uber, 12 rides per second. And of course, Visa, you got, actually it should be 2K, it's 20,000K transactions per second with a peak of 50,000, right? It's early days. We don't know exactly how to build this new revolution, this trustless revolution, but we know it's trustless because I don't need to trust anymore. I don't need the Ben Stiller hug. I don't need the warmth of going into a bank and saying, you're my bank manager, could you help me out? I love you. I don't need that. Because it all happens in a dispassionate cloud. But look, it's dial-up 101. It's early days. So have a great ride, evolutionarily, after this. So thanks so much.